Dzień dobry. My name is Dimitri. I'm a Belgian, and we work around a protocol called Ocean Protocol. What it is, it's basically an open source community. It's a tokenized foundation, so everybody that participates get basically a little bit of equity and rewards inside of our system. And today, I actually already made some impact. When entering the conference, I hit the glass door. There was my impact. If you've seen me, that was me. But today will be more than that. I will be talking about, well, a bit of a vision, but also something for the geeky people to play with, because we have a lot of code. You can find it on GitHub. Don't hesitate afterwards to come and contact me, see if you like this, if you want to contribute. We love crazy ideas. So, a little bit of background. We started off with common infrastructure, the natural resources of the world. We love to plunder them. Because we were good at plundering, there was an era of privatization, meaning that local resources could be owned by a single person or an entity, which grew into an infrastructure that's publicly used but privately owned. Think about mobility, think about electricity sometimes, think about basically a lot of things that you see in the digital sphere as well. Compute services, access to data scientists, etc. There's also public infrastructure run by governments, and that's your public utilities. There you have your water, you have a lot of things like, again, electricity could fall under there. But these are things that we see as a given. And the better your country is developed, the more access to public utilities you have. Decentralized infrastructure actually emerged somewhere in the 60s when there was a huge threat due to the Cold War. So a lot of communications could be basically turned off by a single hit. And if you have critical infrastructure, or you just don't want one person to click one button and destroy the infrastructure, then decentralization is something for you. And what we see emerging out of this is something we call autonomous infrastructure. Less decision-making from humans, more automated processes. Now, when I think about impact, I think about efficiently allocating that infrastructure and resources to solve shared problems. Not only problems that interest a single private company, but actually benefit the entire world. And we can look at progress, for example. What's the World Happiness Index? How can we improve that? Well, imagine you set yourself in front of one of those big problems. Like we work, for example, together with X Prize around the Sustainable Development Goals. So they have a lot of challenges. I think 16, 17 may be growing. And what you'll find is that, well, you would define what's the problem statement, you maybe write out a challenge, and then you hope data scientists or knowledge experts will go out and source data. If you have more data, you understand the problem better, and you might come up with new solutions. Artificial intelligence is emergent out of that data. But that's not so easy. The data has a problem. Data doesn't want to move. Why? Well, often it's behind firewalls. Personal identifiable information, maybe a unique selling point from that data. I don't know if you know about, for example, Google's Sensor Vault, which is tracking mobile information of all these Android users. That's a big asset they have. That's a big USP. Also a lot of PII. That data doesn't want to move, want to stay inside. But often it's more practical. Data tends to be big. Big data, moving it means a lot of bandwidth, a lot of infrastructure to do, a lot of costs. So often you would see compute, like algorithms, going towards the data. And lastly, data is kind of siloed also because it's local. It has local semantics, ontologies, local context. So it's hard to discover often. Now, What we looked around, like, what are models that actually work? And we came to a point where, well, often a data set that's popular and has a community is quite successful. Think about Google has something called ImageNet. You have WaveNet now, which has been overfitted on a lot of sound. So start with the initial problem. One of the initial problems that we have is, for example, look at X-ray data and see if you can predict something like long volume, anomalies, a lot of things. And now you could create something like X-ray net, have a community feeding into that. And then with X-ray net, what can you do next? Can you solve other problems with X-ray net that might not be related to X-rays, but other types of image recognition? There's a few very interesting techniques, and one of them is called transfer learning. You take a neural network that you train on a very prominent data set. Then now you can, once you have this very well-trained network, you can cut off the last layer, and you can use that network pre-trained in another context to solve other problems. The thing we're trying to figure out, can these data sets signal themselves towards other problems to come up with new solutions, rather than going from a problem and sourcing from data sets? Now, I'm oversimplifying a little bit, because we're often talking about data service supply chains. There's a lot of components, but often you can simplify them to training data, testing data, algorithms, compute servers, storage servers, and maybe analytics engines. And that will create a supply chain. But what I want to get is, instead of going from a data service supply chain, go from a solution supply chain, where the data finds potential problems to be solved. That's kind of what we're looking at. That's the hypothesis we have. Oh, that's a back button. There's a back button. In general, what we think is data needs a lot of love and care. It needs humans in the loop. It needs process. So you have human capital, knowledge, attention standards, work from data engineers and data scientists, and also the infrastructure, the digital infrastructure it would run on. These are your servers, your cloud compute, maybe all the libraries attached to it. And what we're adding to this is identity, the concept of having a community around a specific type of data set or data network. And adding to that, the notion of provenance, knowing who did what worked, what did not. And reputation. Data performs well, maybe if you're a stakeholder of the future potential of that data, the unrealized potential of that data, maybe you're incentivized to signal it forward. And say, hey, we solved this, now we might be able to solve that. We know how to predict lung capacity and anomalies. Maybe now we can go and look at autonomous driving and look at anomalies on the road, potholes or things like that. Then the last component, and that's what really triggered me, is what we call governance. Imagine this data set accumulating success and solving problems, and people have a price for their problem. Then the data set and the community around it could get some rewards out of that. But you need to have attribution. You need to have access control. And you need to have incentives. So here's one model I love to work around, is what I call data as an organization. In the middle, you see your data set, and then we added a few components around it. On the bottom layer is the work that attracts, that's basically saying, here is a few tasks to be solved. Tasks could be normalize data, label the data, put it in different formats, create an ontology, metadata structure, all of these things. Work putting in that data will create value, and value, you can look at intellectual property. I'm not sure if that clock is correct, otherwise I'm already out of time, so I'll just assume it's not. Well, the governance aspect of this is basically redistributing the value, creating incentives for people to work on this. creating tasks, having a pool of reserve, could be funds, could be tokens, could be whatever of value that's accumulated by this data set. Why we think it's possible? Because we've been building gradually towards this. First, in 2014, we had something called Ascribe, which is all about creating digital scarcity. We used the Bitcoin blockchain to take creative work, stamp it on the Bitcoin blockchain, and then you have a proof of ownership. You could have limited editions. Digital scarcity is hard because digital is meant to go viral and to be copied. But if you can hold track of the rights holdership, then you can create scarcity in that. Another thing that's very important is to have the full chain of provenance, who did what at which point in time. So we created something we call a blockchain database using BigchainDB. Its BigchainDB basically uses what we call a Byzantine fault-tolerant consensus model. This means that you can it's more attack-tolerant than, for example, a centralized ownership of a database. It's a co-owned database. Now we went one step further and looked at incentives. How can we apply incentives in this entire ecosystem to create public intelligence networks? And that's what we're doing with Ocean Protocol. And we're reusing the learnings from before. A little bit about incentives and why we think they work is because, for example, one realization we had is a superpower of blockchain is that you can make people do stuff. For example, Bitcoin. It has a very simple mining algorithm. It's basically a lottery of hashing. And if more computers working together, you get and you win this hashing lottery, then you get a reward. So what happened? A lot of people started creating dedicated hardware to win that lottery because they saw value in Bitcoin. And this led to an exponential increase of the amount of computing power in this network. So there is an incentive, and people started actually building stuff to hit to that reward function. It's almost time. I just want to leave you with this. Using these types of decentralized substrates allows us to create new types of organizations where we can build in that governance in smart contracts. We call these decentralized autonomous organizations. The cool thing is you can create non-human agents that can own resources, and they can build in incentives inside of protocol. It's more human tolerant. It's unstoppable. Once you deploy it, you can have unstoppable solution finding. Built in that governance, tokenize the attribution and the intellectual property, creating a new form of shareholdership. If you contribute work to the system, you basically become a co-owner of the system. That's it.
Thank you, Dimitri.
Yeah.
Very thought-provoking, very inspiring. Thank you very much. And
I do want you to continue this conversation. You said it's unstoppable, so please don't stop here. Talk to him, come find him and talk to him. Once again, thank you very much.
Thank you.